Okay, so you know the circle theorems, but how do you know that they work? Well, in this video, we're going to prove 5 of the 8 circle theorems, and those are the 5 that you have to learn for GCSE, starting with this one. So we know that when we have an angle x, that this is going to be 2x. But how do we know that? How do we know that for real? Well, the first thing we can do is we can draw a radius like this, right? And remember, as I said in the last video, if this is a radius, then this is a radius, and therefore this is a radius. So now let's label this one x. And if this is x, then this too has to be x. And if these two are x, then it means the angle COA is equal to 180 minus 2x. Yeah? So this is 180 minus 2x. Now let's do the same thing for the other side. So if this is y, remember, if this is a radius, then this is also a radius. This also has to be y. And so therefore, angle BOA has to be equal to 180 minus 2y. Okay? So this is 180 minus 2y. Cool. So now, I must ask, what does angle CAB equal? Well, that's pretty obvious. It's x plus y. But then what does angle COB equal? Well, we know that in a circle there are 360 degrees. So that's just going to equal 360 minus, and let's write down what we have here. We have 180 minus 2x minus 180 minus 2y. And when we simplify that, we get an answer of 2x plus 2y, which just so happens to be double x plus y, which is what we have here. And so therefore, this angle is twice this angle. We do the exact same proof whenever we do this. So I'm going to quickly do it again. If this doesn't make sense to you, literally just do this proof. You might be asked the same thing to prove that if this is 180, prove that this is 90. It's the exact same thing. We draw a radius. We say this is x. We say this is y. If this is x, this also has to be x. If this is y, this also has to be y. This here is 180 minus x. This here is 180 minus y. 2y. 2x and 2y. So therefore this here has to be 2x plus 2y. And we know that 2x plus 2y is 180. Therefore, x plus y is equal to 90. And therefore, we prove that circle theorem. It works the exact same way. What about something like this? How do we prove the angles of the same segment are equal to each other? So let's say this angle here is x, right? What can we do with the circle to show that this here is also x? Well, we also have a center, don't we? So what we can do is draw 2 radii on it. So now we know that this, using this shape here, that this angle here is going to be 2x. And if this angle here is equal to 2x, notice this shape here. It's the exact same. So therefore this has to be x, isn't it? Because otherwise this can't be 2x. Because this, we've proven that this is double this. So therefore these two angles are equal. What about a cyclic quadrilateral? How are we going to prove that a cyclic quadrilateral always adds up to 180? So once again, let's label this x. What can we do to help us with this question? Well, we have a center, so let's draw some radii to show that that's a center. So therefore angle COA has to equal 2x. Now let's label this one y, okay? Again, using the same circle theorem, angle COA has to also equal 2y. Yeah? So therefore, what does 2x plus 2y equal? Well, it forms a circle, so 2x plus 2y has to equal 360. And now let's factorize, so 2 times x plus y is equal to 360. And divided by 2, x plus y is equal to 180. And now we've proven this circle theorem. What about the alternate segment theorem? It's not a quadrilateral, so we can't draw a radius to show off that, you know, that we're using this formula, this circle theorem. How are we going to do it this time? Well, we can still draw a radius, only this time our radius is going to be here and here. And what we can do is we can draw a semicircle, right? So if we label this semicircle, we'll get something that looks like this. Yeah. So if this is a right angle, it also means that this here is a right angle. And okay, let's say, for all intents and purposes, that this angle here is x, okay? What is this angle here going to equal? Exactly. Let's label this F and let's label this G. So angle GCF is going to equal 90 minus x. You agree? Because if this is 90 degrees, this has to be 90 minus x. But remember, this is a semicircle. So this is 90 degrees. So then what is this angle here going to equal? Exactly. That angle there is going to be equal to x. So angle CFG is going to be equal to 180 minus 90 minus x minus 90, which is equal to x. And it just so happens that that is on the alternate segment. So therefore we can say that angle BCE is equal to angle CFG A, B. So that's also going to be equal to X. Thank you guys for watching. I hope this video made sense. If you guys liked it, consider subscribing as it helps out the channel a lot. If you guys have any further questions or comments, join my Discord server. It's the best place to ask me questions, or ask me down below if you don't want to join. If you guys need some extra tutoring, drop me an email and we can organize a meeting and a quote. Keep on learning, as you have no idea what you're capable of doing.